Hi class! So for chapter 9, as soon as you get a periodic table, what I want you to do is I want you to mark off, I'm going to escape out of this so I can show you with the arrow. I want you to mark off 1, 2, 3, 4, 5, 6, 7 for your periods. Then I want you to mark off the first two columns as the S block. I want you to mark off the transition area as the D block. And I want you to start the D block at 3, because you can remember it's 1, 2, 3 columns over. And then, with the exception of helium and hydrogen, which I'll cross off, I want you to mark off this region as the P block. And I want to remind you that these numbers in front show the energy level for the electron, which shows how far away from the nucleus the electrons are. If they're in the 1 level, they're really close to the nucleus. If they're in 7, they're far, far away. And then these letters tell the shapes, and the shapes are probability charts for where you might find an electron. So you have a high likelihood of finding an electron in these particular shapes. I'm going to show you these shapes in just a second, but first I want to remind you how to shade in your periodic table so that you can use this, as shown in the previous video, to find a particular element. And I'm going to go here. We're going to look at arsenic. And what you would do to do an electron configuration is you do 1s, and you'd read it like a book, so you go straight across, 1s, 2 boxes, so 1s2, 2s, 2 boxes, 2s2. Then you're in the P region, so this would be 2p because you're still at period 2. 2p, and if you count, 6 boxes, so that means 6 electrons, 2p6, 3, 2 boxes, 3s2, go straight across like you're reading, 3, but now you're in the P region, 3p6, because these are 6 boxes, and then you go down, 4s, you're in the S region, 2 boxes, 3d, because D starts 1 lower level, 3d, and if you count, 10 boxes, and then 4p. So S and P are always 1 number higher than the D. 4p, 1, 2, 3. 4p3 would be arsenic, and that's the full electron configuration for arsenic. The other thing that you can do is you can take the noble gas that comes before, you can put it in brackets, and you could say argon, and then you continue where argon left off. So you'd say 4s, 2 boxes, 3d, again if you count, 10 boxes, you use all 10 to get to arsenic, and then 4p, 3 boxes, and you'd be done. And if I said how many valence electrons, those would be electrons on the outside, and you're in group 5, so you would have 5 valence electrons, or you could just add the S and the P, which is 2 electrons here, 3 electrons here. Again, the superscripts represent electrons. The numbers in front represent how far away from the nucleus it is, so what orbit it's on. If it's a higher number, it's further away. And then these letters represent shapes, which are regions where you might find an electron. They're also called subshells. So you have the S subshell, the D subshell, the P subshell. I will talk about the shapes and how they fill up in the next video.